This is a problem with a differential MOSFET amplifier that is being driven by a current source. So here's the differential part. And the bottom is the current source. And we're given that we want to design for a GM of 1 milliamp per volt. Find VO1, which is the output, over the differential input, and the CMRR for this, also given the parameters for the transistors. So with GM, that tells us that we can find the current from that. So we can solve this for the current. This is 200 micro. That gives an ID equal to 2.5 milli. Again, remember that this is the current flowing up here. So the current going through the current source down here needs to be 5 milli. So a summation of both of those. The way the MOSFETs work, with the same VGS, this will be exactly the same 5 milli. So to set that 5 milliamps, we need to determine what value of R is going to be used here. To do that, we can take a voltage loop from the bottom up through the top. So a minus 15. And both of these are VGS. The same thing up here. So with this one being tied, I can find, so I know the voltage between here and here. Up here, I don't know the voltage between here and here, so I'm going to take this side because it's tied, and then again I know VGS, and that will be tied to this point here. So it will be a plus VGS from this transistor, and then a plus VGS from that transistor, which is also the same point as here. Then a plus 5 milli times R, and then the minus 15. That's all equal to 0. And I then have two unknowns, VGS and R. So I know the current though, so I can relate that to VGS. I have the current is 5 milli, so I can use the ID equation again and solve that for VGS. I know VT also, squared. So I can solve this for VGS. And that gives a value of VGS at 7.7 volts. So knowing 7.7 volts here now, I can solve for this R. So R will be equal to 30 minus 2 times 7.7 over 5 milli, which gives a value of 2892. So 2892 will set that current to be 5 milliamps, which is what we need to have the transistors have a GM of 1 milliamp per volt. So now the gain, VO1 over the differential input, is equal to half GM RO, and RO is VA over the current going through it, which will be 2.5 milli. GM is the 1 milli. And multiplying that out, it's a value of 10 volts per volt. The CMRR is the differential gain, which is 10, times 2 GM REE, which is the resistance again, seen, this is RSS, meaning source. So the resistance, though, seen from the current mirror. So this current mirror configuration actually looks like it will go to ground and to ground, and so it will end up looking like a cascode. And so the equivalent RSS will be GM RO RO, where the GM and the ROs here are with the other current. So make sure not to use the GM of 1 milli, because now it's 200 micro, and the current flowing through the current source, which is what we're trying to find this. This is from current source. And that current is 5 milli. RO is going to be VA over 5 milli, and there's 2 of them, so squaring that. And then this GM up here is the GM of the top, so I would use 1 milli. So the CMRR, multiplying that all out, gives a value of 140K. Oh, actually RSS is 140K, and this ends up being, so RSS is 140K, and this is 2.8K. So CMRR is 2.8K. So writing these down in summary, we designed for R, which was 2892, and then V01 over VID was 10 volt per volt, and the CMRR 20 log of 2.8K in dB.